Hi, my name is Nurul Aishah binti Zahurin.
Hello, my name is Davanya and my matrix number is 822HP00. Throughout this video, we are going to be discussing about introduction to swing right, concepts of mechanics in swing right, and let's us discuss more about application of mechanics in swing right. And before that, let's us watch a video of how a swing right works.
The rotating swing right have seat attached below a metal structure. Each seat is suspended by metal chain. The right is powered by a motor that makes the swing right to spin around the center axis of the right. The chair moves in a circle at a moderate speed. If we focus on a swing in particular, we notice that the swing moves around the circle at a constant velocity. Did you know it is actually accelerating? In the past, we have learned that acceleration is a change in velocity. However, in circular motion, the object does not require a change in speed, but instead a change in direction. Because the direction of velocity is tangential to the circle, it is always changing, even if it's constant. This is called centripetal acceleration. If centripetal forces are constantly pulling to the inside of the circle, why do you feel as though we are going to the outer portion of the circle? When we are in the swing right, we feel as though we are leaning towards the outer portion of the circle, almost as if we are in a flight. Our velocity is tangential to the circle, which means that our bodies want to continue traveling in that path, but the centripetal forces acting on us doesn't allow us to do so. This is why our body feels as if they are being pushed to the outside of the circular path. Because the centripetal forces acting on the swing and the swings in the shaft are fighting against each other, we feel a lift and motion towards the outer part of the circle. There are three physics concepts that we will discover in the swing right. First is the forces in uniform circular motion, next is the frequency and period, and the third is the speed and acceleration in circular motion. The forces acting on the swing rider are the tension in the chain and the weight of the rider. Since the swing travels in a circle, the resultant force is the centripetal force. The free body diagram on the right shows the forces acting on the rider. The sum of the forces on the x-axis provide the centripetal force, that is, the force that keeps the rider in a circle, the horizontal component of the tension force. The sum of the forces on the y-axis is equal to the weight of the rider. So, by dividing the horizontal over the vertical component yields the tangent sine divided by cosine, we will obtain this important relationship next to me. This analysis predicts that the mass of the rider does not affect the angle at which the swings rotate.
Now we are going to take a look at the application of frequency and period in swing right. So how to calculate the frequency of a swing right? We can calculate the frequency of a swing right by the number of rotations per unit time. Some common units of frequency are RPM, which means revolutions per minute, and the Hertz, revolutions per second. And the period is the time taken to do one complete revolution is given in seconds. Other than forces in uniform circular motion, frequency, and period, the application of speed and acceleration in circular motion also apply in swing right. So the swing travels in a circle at constant speed. The distance traveled is the perimeter of the circle, so the speed is given by the distance covered per time. We can calculate the speed of the swing right by 2 pi r over t. The acceleration is called centripetal and it is directed towards the center of the circle. And the equation to calculate the acceleration is v square over t. From the application of mechanics in swing right, we can summarize that swing represents a perfect circular motion theories, sitting in a seat and traveling in circles effects caused by circular motion. Centripetal acceleration, centripetal force, and directional changes in velocity creates a fun-filled experience. The tension on the chain balances both the centripetal force and gravity to make sure the rider does not continue on the tangential velocity path and enjoys a thrilling, safe ride. The ride demonstrates perfectly the principle of circular motion as well as the centripetal acceleration and force. Hope you enjoyed our video. Thank you for watching.